Hello everyone, good morning, good afternoon, wherever you are. Welcome to Mega Webinar Series. My name is Ali Hussein and I will be your moderator and presenter for today's session. Our session today is going to be talking about first trip testing for HV circuit breakers. You all have been muted to avoid any disturbance during the webinar. But if you have any question during the session, please feel free to ask that question in the Q&A box to the right of your screen. Before we start, I would like to highlight if anyone can hear me, please raise your hand or type in the chat so we can confirm and go ahead. Very well. So again, I thank you for joining us today. Our session about first trip and our agenda for this session is first, I will give a quick introduction about circuit breaker testing, how we do things in circuit breaker, the conventional way of testing. Then I'm going to talk about why the need for first trip was first arise and what benefit we get from doing the first trip test to HV circuit breakers. After that, I'll show some setups, how do the setup for the first trip test, what differences are available between the first trip and the conventional way. And also show some results from real-time tests that has been done, how the result will look like and what you should expect from them. And in the end, as I usually do and try to do, I will do a practical demo. I have my camera set up here with me and the whole setup ready for an actual test. Of course, this test will be in a simulated environment. I don't have a full high voltage circuit breaker that is online with me, but I simulated with some devices in the office. So please tune in and I hope you enjoy and learn a lot from this session. So first of all, for breaker testing in the conventional way, when I have a breaker and I want to do timing test, motion test to it, or even contact resistance test to this breaker, just as a common practice everywhere, it might be different in some steps, but generally it will be most likely like this. First, you will open your breaker, and then you will open the isolators around this breaker to isolate it from the high voltage system. And after that, to make sure that this is a safe area for you to work and connect your test equipment, you will ground both sides of the breaker to establish what we call a safe zone. After establishing this safe zone, whether you are working with an outdoor circuit breaker, a live tank, dead tank, or even a GIS system, the procedure will be a little bit similar. Then you will go ahead and connect your test equipment, whether it's a TM or EGL or any other circuit breaker analyzer. You'll first make sure that you are grounding it to. You will connect your control leads, the trip coil, close coil. If you have open 2 or trip 2, you can connect that as well. Then you will connect your timing measuring leads to each phase in your breaker. Optionally as well, you can connect motion transducers when you want to do a motion test to measure how it's the stroke or the speed of the breaker. You can do that as well optionally. And then if you want to start testing, if you are using the conventional method, you will remove one of the grounds and your breaker is ready to be tested. The reason for that is because when you have both sides grounded, it's become a short circuit across the breaker. So circuit breaker analyzer using the conventional method, cannot measure both sides grounded. That's why a lot of circuit breaker analyzer provide something called dual ground testing for that, which is also will be utilizing the same, almost the same setup to do the test. You still have to isolate the breaker and then connect to it while it's dual grounded. And then you can just go ahead and do the timing, conventional timing for the open or the close position or timing. Basically, what this test does is it measures the resistance of the measured loop and compare it to a threshold. If this threshold is, for example, for open, if it's infinity or more than 10 kilo ohm, it will consider it open off. Or if it less than 10 ohm or short circuit, will consider it as closed position. And I will show you this usually known, very well known graph. So this is the conventional way where we do testing, and it's been done for many years. Some improvement has been added to it by doing it with using dual ground measurement, which is an added safety feature, and also could reduce the some of the steps, like removing the ground again after establishing that safe zone. Now, in this conventional method, the timing test has been done after opening the breaker for the first time, which is where the first trip importance come. You know, the breakers could remain in a closed position for months or even years without being opened. Maybe some rust happens to their mechanical parts, or some dust, or the lubrication got stiff a little bit or hardened, that for the first time when you open the breaker, these conditions get shaken up and the breaker return to its original or specified way of operation. Now, this condition, if you are doing conventional timing, you will already go through it at the first isolation, which what I show in the first slide. But if you have a fault on the system after months or even years of normal service, there is no problem, suddenly a fault happened and the breaker will open for first time in months or years, it will go through this hard stiffen or lack of lubrication or rusty conditions. So it's really a valuable information to have. At the first time of months of in service condition, the first time of a tripping, it is a valuable information to have. It's information that you don't want to lose about the breaker. It will not only give you information about the breaker itself, but the conditions that this breaker is operating in. Is it going to be a dependable breaker after years between tests? If you are testing, your testing cycle is some years, like 3 or 4 years. Between this period, this first trip can give you information what happens between this period. And the test is actually very simple to do. It's not something really difficult that it requires a lot of additional things or all. It's very simple to do actually. So this is what I meant by when you want to do a normal conventional testing, you first you have your breaker closed, you open it, then isolate it, and then do all the connection and do the test. But in first trip, you can start by just measuring the coil current or the trip coil current, because the coil current have a unique profile that you can utilize to see the condition of your trip coil as well as the condition of the mechanism itself, or how long it takes time for the trip coil and the mechanism to fully operate the breaker to make it open. So as a first trip test, you can first start with recording the coil current, and also you can optionally record the control voltage, how much voltage dip happens during this operation as well. So for the coil current, you can see there is like a unique profile, 2 jumps, first small jump and then a long jump. Each jump indicates, or the time for it indicates a certain period of the operation of the breaker. The first jump is related to the coil itself, and the second jump is related to the mechanism. And we will see that in further details in next slides. But this information, you can do it basically while the breaker is in real conditions or an online condition. Just record the coil current during the operation. And once you get that profile, you can compare it with a reference coil current profile or a test value or test result that's been done during commissioning or factory acceptance test, or even a previous result that you got of the same model or the same exact breaker. So how can I get this coil current measurement? Basically, I'm just gonna measure it using a clamp. So this is the first step in doing a first trip test. I'll go to the mechanism where I have my control circuitry or tripping coil and closing coil circuitry, and I'm going to connect a clamp, a current clamp, to measure the coil current. In addition to that, I also can measure the control voltage, and in order to make sure that all my measurement is in sync with the operation of the breaker, I can take a trigger from the control command and put this trigger into my control or my circuit breaker analyzer. So the circuit breaker analyzer will know when to measure the circuit breaker current and time it correctly for the reference value as well. Optionally as well, you can also connect to your auxiliary contacts if you would like and see how they operate as well. Now, if you want to go even a further step as well in doing first step testing, you can not only see how the coil current and voltage look like during operation, but also you can do an actual timing test. And in order to do that, in your switchgear system, where you have your circuit breaker, disconnector, bus bar, you also have your CTs, where they measure the current flowing through the breaker when you have a load or a fault condition, but usually in normal load condition. Now, these CTs I can connect to their secondary wiring using an additional external clamps. And from these CTs, I can measure the current flowing through the breaker. When I open the breaker, this current will get interrupted. Of course, in order to measure that current, you'll have to have a line that is loaded to have a certain percentage of load. 10% to and above will be recommended to do this test. Below 10%, it might give you a shady result because of the errors and so on of the CTs and the clamps as well. And it's recommended always to connect them to protection CTs because they can handle the extra burden by these current clamp as well. So combining the coil current measurement and the measurement of the CTs during operation, I can do first trip test and timing test as well while the breaker is online. And this is one of the advantages of doing the first trip test. You don't have to really take it out of service to do testing. You can do it as an online test. Of course, that comes with a lot of limitations to be done. So I would really advise you to be careful in planning this or considering this as an online test alternative to the conventional method as well. The conventional method still needed to be done. This is only give you the advantage of checking that first trip condition. The first time you operate the breaker after a very long time in service, months or years, to see how does it stand with all this time in service. And this is example result of an actual test. You have below the coil current measurement. You can see the two jumps, the first jump and the second jump. And the second measurement is for the voltage, control voltage. You see it dips down a little bit during the coil current measurement. And on top you can see a sinusoidal signal indicating an alternating current going through the load or through the protection CTs of the breaker. Once the breaker opens, you see that current goes to 0. So you can even find out what is the actual or similar to actual breaking time of the breaker, in addition to the coil current and voltage. Basically, an online test utilized for first trip testing. Now, for the coil current, I mentioned to you that it has its own analysis. There are some things you need to know about the coil current in order to be able to analyze it correctly. So first you have the peak, how much maximum peak the current or the coil is drawing. Then you have the armature start peak. This is the first jump. You need to see how long does this first jump take and measure that time. And then as well, I have to see how long the mechanism takes to fully operate the breaker, because these timers are important for me to see if I have a problem within the mechanism of the breaker, like a mechanical problem, a bad lubrication, a stiff hydraulics in case I'm using springs or any of these issues, or my trip coil itself is having a bad winding resistance, or having some shortening inside this coil, or the armature inside this coil is stiff or having a bad lubrication. All can be seen from the first jump and the second jump times. So this is another example of a coil current, just to give you a comparison. If I do this, for example, this year, and then I do the coil current another year, it might give me different shapes and times. So the condition I'm seeing here, I need to compare the small jump with the small jump and the big jump with the big jump as well. Just for comparison, you can see that the whole duration is being delayed by the small jump itself, having a longer time from the previous one, thus meaning that I have a bad or a coil that is not working properly as it should be. This is usually happens in first trip test. When you do this, you find these singular differences in the test. But once the breaker is operated once, and it's going to be operated twice and 3 times or 4 times during the conventional timing, this condition will just clear away, because during operation the breaker get liquidated and remove any rust or dust inside these mechanical parts. So I can compare these and see if I have any problem in the coil winding or coil armature, or even the voltage system could result in this condition as well. So what advantages that first trip give us, it will give you real life trip time. Means what happens when an actual fault happen after many years of in service, many years or many months in most cases, after very long time of not being operated, what the actual trip time will look like. This is what first trip gives you. If you have any lubrication or corrosion problem, you are in open area or outdoor circuit breaker, you have any leakages or any dust coming in into your mechanical compartment, it will be revealed using first trip test. It is very simple and easy to do. You can do a reclose operation, open, close, again with this setup while it's online, and just like a quick test without requiring it to be out of service. Although, as I mentioned earlier, this thing need to have a lot of preparation to be able to be done. Also, it's very recommended to always do first trip before taking the breaker out of service for haul or overhaul, to see what that first trip condition will look like. So these advantages that give us with the first trip, I would like to show you a practical demo of that, to just show you how easy it is actually to do the test. You don't really need too much things to do the test as well. It's very simple, and you can do it while the breaker is online. This is the first trip kit that we supply with our TM17 and or 1800. It's basically just contains current clamps, 3 current clamps for connecting to CTs, protection CTs, or to measure the timing, and whether you have a single mechanism or a separate mechanism where each phase has its own mechanism. Your trip and closed coil, you can connect a coil current for it. So you either have a 6 clamps or 4 clamps, 3 being for the CT and 1 or 3 being for the coil measurement. And it has its own test plan to specifically to the TM17 or 1800. So for our practical demo today, I'm going to do the first trip and timing test together. So this is our configuration. I will be connecting or simulating a breaker like with a connected CT, and also I will be measuring the coil current at the same time of the breaker while taking the trigger to my circuit breaker analyzer. In order to simulate this, I'm utilizing our breaker simulator demo unit. It's basically simulating a breaker, 3-phase breaker with a single mechanism. And this will simulate for me the coil current and the control voltage. But if I want to show a CT current, I'm utilizing a secondary injection test equipment, the Spherker 900. It's a 3-phase secondary injection test equipment where I will inject secondary currents. Now, these are just for this practical or simulation demo. In real life, you will have a breaker that have a coil and will have CTs connected to your protection system where you can measure out of them. In order to control this breaker, as I mentioned, this is an online test, so I will control the breaker either from the bay control unit, or I can ask our control systems or SCADA people to control the breaker for me, either to close it or open it. Of course, I will do this after connecting all these measurements and connecting to my TM17 or 1800. In my setup example here, it is TM 1800. I will put this TM1800 in a passive measurement mode. Basically, start doing measurement until the trigger gets to you to capture that certain period of time. So let's open my camera and showcase this setup in real life. So this is my camera now. And the setup I'm having here with me, I'm having the TM1800 in passive mode. I'm having the circuit breaker simulator with me here, as well the Spherical 900 to simulate CTs for me, and the relay to control both these two for close and opening position. So first of all, the test plan that you are going to actually do is not related to these two. These are just simulating a breaker. It's related to these clamps I'm having here. I'm having 3 clamps. Let me zoom in more for you to see. I'm having 3 clamps. This is for blue phase, red phase, and yellow phase. This is to do timing test through the simulated CT. And I have a 4th clamp here with me. This is to measure the coil current from this circuit breaker simulator. So I'm gonna put this all clamps to on mode. Now, in order to simulate an actual current in my breaker, I will start injecting some current from my Spherical 900 into my relay. So I'm going to, I already set the values for it. I'm going just to inject the current. It doesn't really matter how much the current, but it shouldn't be a very low current as well. Now my breaker is in the closed position and it is having some current values in it, like in service condition for a very long time. I can see that in my relay as well. Here I have my CB closed. I'm going to utilize this relay to open or close the breaker as a control pulse. But before doing that, I need to set up my TM1800, do all the connection to it, and start a recording value. Going out. By the way, I hope everyone can see my screen very well, or my webcam. If you do, please put the raise hand button if possible. Yes, thank you. So I'm going to zoom in into my TM1800. I'm choosing the first trip plan. It comes with the first trip kit. And basically it's just consisting of configuration for the clamps itself, how much the ratio for the clamp, how much ampere per volt, or all these sort of things. And I can click on it, the first trip test, and just basically start the measurement. When I start the measurement in the TM, it will not trip anything or actively trip the breaker, since it's in passive mode. It will basically just wait for trigger in. Basically wait for the trip pulse from the relay or SCADA system to my breaker, and upon that it will start doing the recording. So see the wait for trigger in. Now for my trigger in, I'm going to utilize my relay to do that. So I'm going out. I have my Spherical 100 injecting, my breaker closed. Now I'm just going to trip the breaker utilizing the relay. So going to the options of the relay to trip my breaker. Of course, you can ask the SCADA system to do this for you, but you need to make sure that everything is prepared, all the clamp is on, and so on. So I have my trip and close condition. I'm going to select the trip condition. Now my breaker has been opened, and you will see directly the TM giving you the result. Let me go out, go back to the TM 1800 and stop the measurement and show the result. So let's zoom in then the result and see what do we get from this measurement. Of course, this is a simulated value, so some of the numbers might not be add up or not true, but what you will get in the site is even much better. I'm trying just to provide you with a pretty much similar experience to that as well. So if you are familiar with the TM 1700 or 1800, then you are familiar with the graph layout here, but just as a quick reference, I have here my 3-phase CT currents, phase A, B, and C. In addition to that, I'm measuring the coil current. Unfortunately, this coil current is very small, so it has a lot of noise to it, but still you can see the two jumps, the first jump here and the second jump, indicating the coil current time and the armature time as well. So the first trip test basically takes for the timing, you take the current when it goes to 0. It will not always be accurate to go to the parameter tab and see the opening time. For example, you can see here open time for phase A, B is 60 something millisecond, and there is a huge difference between them, while open time for phase C is 24 millisecond. This because of the current going alternating between plus and minus, so it is difficult for the test equipment to really give you a clear result on that. But what you can see is the graph itself. In the graph, if I zoom in, you can see the 0 value starting from here. Let me go to the left a little bit. Here I'm having my 0. This is the reference where the trig in came. And you can see my coil current starting increasing. After certain time, it's 60 something millisecond. I can even zoom in more to see that. My coil current has extinguished to 0, and my actual phase current has been eliminated to 0 as well, and thus showcasing me some time values and the coil current values as well. Of course, you can always compare the coil current with the previous result using the advanced analyzer in the TM 1800, where we have the advanced analyzer in the test equipment. So you can go back on this measurement, go to system setting, the hardware setting and take the advanced analyzer tool. Open the same recording that I got here. Now you can do all kind of comparisons and having cursors and all. In addition to that, you can use the compare feature where you insert a previous result to this result all on top of each other and do comparison to them directly inside the screen of the test equipment. This is the first trip test. You can also do a first close if you would like to do that, but it's basically the same information, just doing it in reverse. You start the test and wait for the close pulse from the control system. That will be all for our session today. It's been a light session since first trip really is not having that much into it. I'd like to really thank you very much for joining us today, and I will be answering your question now. For anyone leaving, please feel free to fill the form at the end, as your feedback is very important to us. So let's start answering some of your questions. So the first question I'm having here is about doing the online test. Yes, it is an online test for the breaker. The breaker need to be an online condition and service condition, need to have load current to be able to do the timing test at least. And I would recommend that load current at least become 10% of the CT ratio. Below that, the clamps will have some difficulty, maybe giving you a very accurate result as well. So yeah, you need to plan for that ahead. It's not just connect now and just ask the operation to close or open the breaker for that. Second question is I'm having regarding what about having 2 trip coils? You can only energize one to do this test. If you want to do the second one, you can utilize that as well. But from what I see is that for the first trip, since it's called first trip, if you are planning to do first trip, any one of them will do. And you can see its condition at the first time. But if you are planning to use this test concept as an online measurement method, where you do it like an online, you can alternate between these two. Just basically change the coil current from the first one to the second coil, since you cannot energize them at the same time to release the coil. I mean, practically you might can do that, but I don't know how benefit that will give you to utilize both coils to do that. Another question I'm having is regarding the armature current. The armature current, as I mentioned to you earlier, is the how much current the coil draws when you first open the coil. Let me go back to that slide to better explain that question. Yeah, this first jump here. It should not be too much current as well. That's indicating you have a problem with the coil requiring more force to, or the armature, I'm sorry, requiring more force to move it. But also what you should look at is also how much time does this armature current goes for. That will indicate for you the speed as how much this armature is moving in, and also if there is a problems with this latch or this armature, is it having problems, or is the winding around this armature is been shortening with each other. Having another question is regarding the two jumps in the coil current. Are they harmonic? I'm not sure to understand very well your question, sir, but harmonic contents basically comes in periodic signal. This is just a pulse that will happen for a very short time. So we can't really use the harmonic terminology here with the coil current, since harmonics are related to a periodic signal that will keep repeating itself. It's basically the multiples of the fundamental frequency for the harmonics. So it's not really related to that at all. Basically, just the time of each jump, the first jump for the armature and the second jump for the mechanism itself. or in order to explain that even better, let me open a different presentation showcasing what actually happens inside the breaker during coil current measurement. Just one moment. I will open my screen again once I open that presentation. Yes, this one. So, hope you all see my view. So, when you want to do coil current, what does happen into your how does your coil current and armature and mechanism all work together to operate the breaker contacts? So you have here your coil, and you connect a clamp to this coil or measure directly the current coming through this coil during the operation. So when you first give the close or open pulse to your closed breaker, here you have the main contacts of the breaker. This is usually in maybe SF6 gas or air blast or whatever interrupter you have, and these are controlled using a mechanism, a mechanical device that store energy and then release it very fast to operate the breaker. This mechanism is controlled by a coil. It's like latching this mechanism. This coil is holding this mechanism from being released. So when I give a close or open command, whether close or open, both of them are theoretically the same. When I give a close command or open command, an armature inside this coil will move. This armature, whether it will go up or down, doesn't really matter, but the movement of this armature will give me the first jump. This is the coil motion, we call it. Then once this armature reaches its final place, it will release the mechanism. It will be released, and the mechanism will release the energy in it and open the breaker very fast. During this first or this release duration, a second jump will happen in the coil current. You are still measuring the coil current. A second jump will happen to it. Once this mechanism reaches to a fully open position, it will operate an auxiliary contact. We call it 52A, ready to close or ready to open contact. It will open that contact and open the circuit for the coil current, and the current will drop. You'll see the current dropping to zero again, meaning that you have fully opened the breaker. Now, with this, the first jump indicates how much time my coil current or my armature takes to fully reach its final position. Once it reaches its final position, now the mechanism should start to release the energy stored into it, whether it's a spring, you are storing it in a spring, or a pneumatic system, or hydrogen gas, or whatever system that you are using for the mechanism. That's why I kept it just like a box here. This stored energy will operate the breaker, whether it's for close or open position. This is, of course, in a simple way for you to understand how the coil current measurement looks like. Of course, in real life, it might have some additional things to it as well, but this is the basic idea. I hope that answer your question regarding the armature time and current as well. It seems like another question also came in. How can I measure trip coil current online? The trip coil current, as I mentioned, and also from the picture shown here, it's only going to be measurable during operation, whether so this whole current actually, this whole current that you see here, it's only maybe 30 or 40 milliseconds in time, so you can only see it during operation. Otherwise, if you see a normal current in your coil during a normal condition, that's not a very good thing, because that's only specified for operation, whether you are doing close or open at that time. So if you are meaning by online measurement, while you mean this breaker is in service, you need to connect the measurement clamp to the coil, and once that is set up and done, you'll turn on your test equipment to start measuring and to receive the trigger from the breaker tripping or closing by the system or the system operators, and then you can get this measurement value. Another question I'm having here is what is the main difference between first trip and conventional timing? Is online testing? Yes, this is one of the main differences between them, is that it's online. Conventional timing, you cannot do it online. You have to take the breaker out of service and connect to it and do all the measurement while it's out of service and isolated from the system. While the first trip test, you have to do the test while it's online, especially if you want to do the timing test at least, since you cannot get the current in the CTs without having an actual load going through the, or current going through the CT itself. Regarding the slide open, and another question also is regarding the slide open and the close breaker. Can you show us the measurement in real life? Yes, the picture I show you, that was taken from a real life measurement. Let me just show that again. For example, this is a real life measurement for the coil current, and for the this one, this is a coil current and timing test at the same time, utilizing the first trip concept. And this is a real life measurement, by the way. It's taking the breaker at least like 31 or 32 milliseconds to operate, which is for all the breakers, or even I think even modern ones now, it is still real time of them. Unfortunately, I don't have a real breaker here with me that can have a an actual load current through it and do the whole breaking real for you. So that's why I utilize this whole demo concept for that. Let me show you that one. The Spherical 900 and the breaker simulator for that. Another question I'm having here is, what about motion test in brief? The motion test also can be done here. I didn't do it with the first setup, but can be done as well, since it's related to a mechanical part. You can connect to this mechanical part as well. But here, one thing I need to really mention is that when you want to do any connection to a mechanism that's not being operated for a long time, you need to be careful not to touch anything and by mistake releasing that stored energy inside the breaker. As I mentioned to you, it needs to operate very, very fast. So there is a huge amount of energy. That's why you hear the bang sound when you operate the breaker. It's basically this all mechanical energy stored being released in a very short time. So yes, you can do it, but I would advise you to do it with the conventional more than do it with the first trip. The first trip just do the coil currents and CT currents, since these things you can connect to without worrying about anything. But for the motion, to be honest with you, from safety point of view, I would not recommend to do it while doing first trip test. But during conventional test, yes, I will definitely recommend you to do that. But don't forget to release all the stored energy, then connect to the mechanism using the transducer for added safety as well. Another question, continue to previous one, is I didn't get you very well with that, but what I mean is by my question is infinite and zero. Are you talking about the conventional timing measurement method from the first slide, or something else? I'm not really familiar with that. If you can clarify that, I'd be really thankful for that. Another question came in as well. How can I check CB motion and conventional test? I never done this test before. The CB motion, we utilized a transducer. Basically, it's a device that convert the measurement from motion measurement, whether it's a linear or angular measurement, and convert them to an electrical signal. And I connect it to my test equipment, a circuit breaker analyzer, and measure that motion. I have a slide particular to this test, so let me open that, another presentation, and show you. Yes, where is that one? Oh. No, not here. 1 second. One second, I will share my screen again, but it's looking for that particular slide. Yes. So for motion testing, as I mentioned earlier, the breaker have a lot of mechanical parts. Some of these mechanical parts move in a linear way or linear method. They just go forward and back, like the contacts in the breaker. They just touch each other or touch away from each other. And some of the parts are moving in an angular way, just rotating half a cycle or full cycle. Now, these two motion types, either we call it linear or angular motion. To be able to capture them, we need to connect a transducer. If you go and look for transducer or motion transducer in particular, you will see a lot of type of them. Some of them use something we call analog interface. They give you the measurement in millimeter or, in milliampere or millivolt, and some of them are utilizing a digital interface. They give you the information as pulses, how this much degree or this much millimeter in pulses. This is the devices we use to measure the motion test. You can use this in EGIL, in TM, but you have to have the interfaces available in your devices if you want to do this measurement, and also have the transducer for each particular circuit breaker. You need to know your circuit breaker where you can connect it. Another question is asking how to differentiate between the two motion sensor types. I want to buy one and want to select the appropriate one. For that, please email me. I can help you further in detail regarding that and give you what is the best option depending on your circuit breaker situation. I don't know if you can see my email. That's the presentation, yes. Email me please at ali.hossein@migar.com. And I will require you to provide some information regarding the breakers that you are testing, because there is a lot of transducer types. If you go to our circuit breaker accessories, you will be overwhelmed by them, really. That's why you give me the information regarding that, and I will help you select which one is the most appropriate solution for you. There are some additional questions here. I see. Unfortunately, I will not be able to answer them all because we have reached the end of time for our webinar today. I would like again to thank you very much for joining us, and I hope you enjoy and learn a lot about first trip, how it's done, and what benefit you get from it. If you have any question or any doubt about anything, you want to further know about first trip or see a more detailed live demo regarding that, please feel free to drop me an email at any time, and it will be my pleasure to answer you with that. That's it for me. Thank you very much, and please, after you leave, feel free to fill in the feedback form. Thank you very much, and goodbye.